33. Destroy sequential targets. So for this problem, we are giving a zero index array nums, and which consists of positive integers representing targets on a number line. So it's going to be positive integers inside the nums, and we are also giving an integer space. So what we're going to do? So we have a machine which can destroy targets. We just want to destroy the targets. So the target is just inside of the nums. So we're going to fill in the machine with some number nums I, allow it to destroy all targets with values that can be represented as nums I plus c times space. So this c is just a negative integer. So what is the meaning? So if the space is 2, for example, we can choose a seed. For example, the seed is 1. This means we can choose nums I, it is 1, plus c times space. If space is 2, c is 1, so it's going to be 3. If c is 2, so it's going to be 5. So it's going to be something like 1, 3, 5, 7. So if we choose all those odd numbers, so how many of them? In total, it's going to be 5. So this is going to be the maximum of targets we can destroy. Yeah, but we need to choose the minimum value, so it's going to be 1. So what if we choose 0? So if it is a 0, if we choose instead of 0, what if we choose a 2? So it's going to be 2, 4, 6, something like that. Yeah, but we can only destroy this number 8. Yeah, because we want to destroy the maximum number of targets in nums. So this means we must find which one going to be the maximum, and then we're going to destroy them, and then we find the minimum number, smallest number. So according to the constraints, so the nums length is 10 to the power 5, and space is 10 to the power 5, and nums I is 10 to the power 9, and the space is 10 to the power 9. So this means we can use the modular property to solve the problem. So for example, for any number that modular a space of 2, let me think about it. So let any number modular a space of 2. So for example, 3 modular 2 gonna be 1, 7 modular 2 gonna be 1, 8 modular 2 gonna be 0, and this is 1, 1, 1. So how many ones we find? 5 ones. So definitely we're gonna return this one. So definitely we're gonna use a hash table to solve the problem. So according to the modular property. So for n inside the nums d, this is our number. So we're gonna use the number modular space, gonna append this number. So now what is inside of the dictionary? Let's just have a check. Yeah, as you can see inside of the dictionary for the first example, it is 1 with all those values. We just needed to choose the minimum. We just needed to find the longest group, and then we're gonna return the minimum value. So this is gonna be much easier. Yeah. So I'm gonna prepare a maximum of group, and the final result is gonna be 0 on 0. Now we're gonna check the array in data values, because we just need to check the value for those for the modular result like 1 and 0. It doesn't matter. We just need to check anything inside the array and how many arrays. Yeah. And from here, we can prepare a length. So let's define it maybe n, and the minimum value. Let's just use maybe L, and the minimum value. Let's just use this one. So L is going to be length of A, and the minimum value is going to be minimum of A, right? Yeah. Now what are we going to do? We just need to have a check. So if this L is more than the maximum group, so this means we need to update the maximum group. So the maximum group going to equal to L. Yeah, but what if L equals to the group? So for example, L equal to the maximum group, and then we need to find the lowest value. Yeah. If they are equal, and the minimum value is less than the result if this is less than the result, so we're gonna update the minimum value as well. So the minimum value gonna equal to this minimum value. Because for the first time, definitely we cannot find an equal. It must be something L. This L gonna more than the maximum group because it is 0. So after that, definitely we're gonna have a result. That result gonna be this minimum value, maybe 1 or 3 or something like that. And then if we can still find some value which is less than the minimum value, definitely we're gonna find the minimum value. So finally we're gonna return the result. Let me just run it. As you can see, it works, and let me just submit it. As you can see, it works and it's pretty fast, and the time complexity is O(n) instead of O(n) squared. Maybe you think here, it is O(n), but here we're going to choose the minimum value. It may be another O(n). Actually, it is not like that. Actually, the time complexity is NA O(n), because it is dependent on how many values. Because if there are 10 to the power of 5 unique values after the modular, it is okay. So while we are checking the minimum of A, because there's only one element, so the time complexity is still O(1), and for here it is O(n), so the time complexity is O(n). But for the worst case, maybe after the modular, there's only one array, so what are we going to do? So for this tag, this is just O(1), but for here, minimum 10 to the power 5, this is O(n). So anyway, the time complexity is O(n). We have to understand how to analyze this kind of a time complexity. Because it just depended on how many groups. Actually, we just check the element one by one. The time complexity is just O(n). I think that's all for it. Thanks for watching. See you next time.